So today we are going to delve deep into the atom and the wonderfully strange world of quarks, or quarks depending on your preference.
The elementary particles, the gateway to the particle garden of unknown.
So I welcome you to the wonderful world of particle physics.
With Laura, Charlie and Ebony.
Before you thought you knew it all, a GCSE world consisting only of neutrons, protons and electrons combined together uniformly to create everything that has ever and will ever exist.
Well, you would be wrong. There really is more to life than protons, neutrons and electrons, and I'm not just talking in terms of making friends. For our journey through, we will start at the very beginning, most certainly a good place to start. Matter, that's where we begin, and its arch nemesis, antimatter. Well, for the sake of this video anyway. That doesn't matter. Matter and antimatter will be split into leptons and hadrons.
Hadrons are the shiz. They will interact with the strong force, but don't be fooled, leptons are equally cool, even though they don't interact with the strong force.
Let's look at leptons. Woo! Alliteration! You may have thought that matter couldn't have so many hidden gems.
First we have the wonderful electrons, known for being small and equally negative with a charge of -1.
Its nemesis, the positron, or anti-electron, is equally small, but is very positive and has a charge of +1. Both of these will interact, woo, friends, with their neutrino pair, which has the same mass but has no charge.
Also a lepton is the wonderful muon. Muon sounds kind of like a barn animal, I suppose. The muon is also a very negative particle, strange considering its fundamental. Get it? But don't worry. Woo, friends!
The muon will interact with its corresponding neutrino, which is the muon neutrino, which as said before, has no charge.
For us to understand the hadrons, we will first need to look into quarks. These make up the hadrons. There are 3 types of quarks. Up first we have
the wonderful up quark. Hey, feeling optimistic there? Which has a charge of +2/3.
Confused? You should be. Next in the ring we have the down quark, which has a charge of 1/3. Quarks also have something called spin, and no, I'm not talking washing machine cycles. I'm talking about the direction in which they move.
When this changes, this is how a proton can change to a neutron in beta plus decay, because the spin changes on one of the quarks. Make sense now?
The amazing hadrons can be split into baryons and mesons. The reason for this is actually quite interesting.
This is down to whether they will decay into protons or not. Confused? Yes, all of the baryons will decay into protons.
So theoretically, everything eventually will consist of protons. Imagine that, the world a bundle of positivity. That sounds more like it.
The mesons, on the other hand, won't decay into protons.
That's very negative. No, they won't be electrons. They just won't decay into protons either. Please tell me you're confused now.
Now we know life through the eyes of a quark.
Do quarks even have eyes, though?
We can understand the hadrons and what makes them up.
First up are the baryons. Hey, sounds like Barry.
A baryon consists of either 3 quarks or 3 antiquarks.
But never a mixture. Hell to the no. That would just be, well, it wouldn't. Too much duck in the room. Swimming nicely along.
Every quark has a baryon number of +1/3, and the antiquarks the opposite. This means that baryons have a baryon number of +1, and antibaryons have a baryon number of -1.
This seems to make logical sense now, considering they are antimatter. Oh, so Barry has a number? Physics just got a lot cooler.
Next we have the mesons. These also are lovers of quarks. Are you confused now?
Mesons contain a quark and an antiquark.
This is why they do not have a baryon number, unlike the baryons, as the baryon numbers will in fact cancel each other out.
So not 2 quarks, not 2 antiquarks, not 3 quarks or 3 antiquarks, a quark and an antiquark.
Got it? Well, if you're confused, that's probably a good sign too.
Mesons can be split further still into pions. Pi. Well, not edible pi, more a maths and physics pi of knowledge.
Which can either be charged +1, neutral, or -1.
This same rule applies to kaons. Well, kind of like cake, I suppose.
These can be charged +1, neutral, or -1.
This means they're pretty much similar, right? Impressed? I thought so.
I hope you enjoyed our look into the wonderful world of physics.
Well, the matter and antimatter side of it anyway.